Hi Rishi, pleasure meeting you. Thank you for taking the time to speak with me. Now, in the world of data center networking, we're seeing a very vastly different world from the past. With AI driving all the changes, it's no longer just about port speeds and port counts like it used to be. In the context of the history of networking and data center networking, how are you seeing this? How are you framing this at Marvell?
That's a good question. With the evolution of AI, the whole networking space is getting disrupted. The network architectures are getting disrupted. The networking protocols or the normal traditional Ethernet protocols are no longer meeting the needs and the feeds of AI. And this is because of the traffic what AI is handling today. Massive traffic, and this traffic is causing basically innovations in the way network has been architected, and that has a direct impact on way the switches have been architected. And when I talk about this, it is basically no longer the 3-tier architecture, but more of a 2-tier architecture. There is more, I would say, flatness in the architecture and more predictability in terms of the job being done, and also reliability comes into place among the links which are there. Because mind you, when the AI is being on the forefront, a lot of these GPUs are taking a massive amount of power and time to get the job done. You're talking about months of data mining which is happening, and if these networks are not able to give you that level of reliability, then all the efforts kind of get washed and things have to be reiterated. So from a network architecture point of view, the issues which were not considered before, Ethernet was a lossless protocol, and it has been, but people were still looking into more reliability when it comes to AI.
I think AI definitely, in terms of the workloads, whether it's pre-training or inferencing or even the fine-tuning processes, the architecture, as you say, is changing. It's no longer the old 3-tier. It's not even a simple 2-tier clause. It's a front-end network, which looks more like the cloud networks we're familiar with, and the back-end networks, which are very critical for pre-training. So in terms of the impact of AI on these network architectures, there is this term, we now talk about, the scale up versus the scale out, and obviously now scale across as well, just given the constraints of the data center and the power. Let's talk about the impact of scale out networking. What are we seeing in scale out, and what are the key things to be watching for?
Good question. In terms of scale out, number one is the massive amount of bandwidth. Scale out is predominantly driven by bandwidth. So as we transition from 800 gig to 1.6T and forward looking into 3.2T or 6.4T connectivity of the optics, scale out comes into a dominance. So scale out is normally driven by the bandwidth, and the other aspect of the scale out is due to AI, there are protocols like UEC, which is Ultra Ethernet Consortium and all, which are emphasizing on other aspects of AI, which is dynamic load balancing, link level retry, and credit-based flow control. These are, I would say, inherent aspects of AI which have been infused in scale out. And that's what we are seeing today. And scale out is all about 51 tera, 100 tera, 200 tera of switch bandwidth, which is coming into consideration with port speeds of 1.6T today.
Yep. And that's, I think on the scale out side of things, as you point out, we used to have the Ethernet, Rocky V2, and now with UEC, UET, we're seeing sort of the new revision on that. But the key element, as you indicated, is the speeds are still important, high radix is still important. And I think, on the Marvell side, the Teralinks family certainly plays a big role in there as well, right?
Absolutely. Teralinks is actually one of the dominating aspects of our core switching technology, which is driving the scale out, I would say, roadmap. Today we gave you a preview of our 100T fabric, which we would be announcing very soon, and that kind of precedes our 51T switch, which is the TL10, which is in production, and these are all targeted towards scale out. We are committed towards addressing the market needs for scale out, and it will be followed with a 200T switch as well.
Excellent. So let's switch from scale out to scale up. There's been a lot of talk around scale up. It's been a lot of activity around that. Obviously, there's been a lot of conversation around the fact that a lot of it's vertically integrated with NVIDIA, one of your partners, right, with UALink, and then with UALink Fusion, which Marvell participates in as well. So talk to me about scale up, right? What's the nature of the scale fabric, and how is it different from scale out?
Interesting one. And actually, I would say a year ago, nobody was talking about scale up, and suddenly this new term has come up. And it's very critical, and we are at that point where the industry is looking at a compute fabric and a network fabric. We never looked at it in that manner. And the reason why we are looking at it is because when we talk about AI, we talk about clusters of these GPU pods. PCI was the dominant interconnect and it was the de facto stuff. But as I had mentioned, the compute I/O is not being able to match with the feeds of the network I/O. And that is driving the need of this class of a fabric, which so-called as a scale-up fabric. Scale-up fabric is nothing but unification of all of your GPUs or XPUs into one common pod. Now, why do we need this unification? It's something like which we had in the CPU's world, multi-core design where CPUs were within there and a workload from an application or a work process from an application was thrown to these multi-core CPUs. Similarly, in case of AI, these GPUs are doing the workload for millions and trillions of parameters which have been thrown at them. And the unification is necessary because you don't want any of these GPUs to be starved or to be overutilized or oversubscribed. We want to make sure that these are operating in tandem, in synchronicity, so that everything is done at the same time. And plus, you are forgetting we are spending the highest OPEX on these GPUs. So we want to make sure that we are getting the maximum return and optimal operation. So you need a fabric which is kind of tying these GPUs together where they share the common pool of memories. And since I'm talking about memories with this fabric, it becomes different than the network aspect of it. When we talk about network, it's all about quality of service, broadcast, multicast. Those are the aspects of network protocol. When we talk about the scale-up fabric, we are talking about memory sharing, load and store, atomics associated with it, and hence latency comes into play, very critical, and also the bandwidth comes into play because these GPUs, as the generation progress, they are having more horsepower in them and they're capable of crunching more and more data, which is effectively the bandwidth.
Excellent. Now, with regard to some of the protocols there, we touched on NVLink very briefly, but what else is in play in terms of the technologies associated with scale-up?
Yeah, with scale-up, what has happened is it's an open field, and there are different so-called consortiums which have been proposing different proposal in ties up with the OEM or with a strong hyperscaler who's enabling it. So we have two protocols which have been emerging protocols and promising to solve the problem of scale-up. One is ESAN, which is Ethernet-based scale-up network, and the second one is the UALink, which has been kind of driven by AMD and other members of the consortium who are proposing this, which is based mainly on the grounds up on the memory semantics aspect of I would say PCI, but it's exactly not the PCI protocol.
Excellent. And Marvell plays a role supporting both?
Yes.
And NVLink Fusion, I guess?
Yes. Actually, Marvell is in a unique position where we enable and kind of support all three of them. We support NVLink in form of NVLink Fusion. We do support UALink. We are contributing members of the UALink consortium. And similarly, we are active contributors of the ESAN committee as well.
Excellent. So you're playing all sides and enabling all sides?
Yeah, the reason is very simple. We do multitask. We are ultimately into silicon engineering, providing solutions. We do custom XPUs and we do switching also. And we see that there is no one for all kind of a solution here. The market is kind of quite split. People have their own choices, and those choices are based on the workloads they are doing. They have done their analysis in what is favorable for them and what is more practical for them, also what is meeting their timelines. So we are enabling switching for both the UALink as well as ESAN, and they have the same capacity and they are leveraging our engineering resources. On the same note, it also gives us a huge advantage that as a custom compute enabler, we are able to address the needs of both the markets, the UALink as well as the ESAN.
Excellent. And so as a Marvell customer, right, or partner, what should we expect in the near future over the next 12 to 18 months? What can we expect from Marvell in the data center switching space?
Definitely, we are committed towards our scale-out roadmap plans. So it will be basically the 100T and the 200T fabric. We are going double down on the scale-up roadmap, where you will be seeing our UALink 115T and 57T fabric devices. Along with it, we'll have a dedicated ESAN fabric as well, which will be of 115T, and all of these would be available in the early half of 2027.
Excellent. Looking forward to seeing all that in the market.
Same here. Thank you.
Thanks, Rishi.
Thanks.
Really
Thank
appreciate
you.
it.
Thank you.
Thanks for your time.